Ernie makes deposits of 100 at time 0 and X at time 3. The fund grows at force of interest delta T equals T squared by 100. The amount of interest earned from time 3 to 6 is also X. Calculate X. Okay, so since a new deposit is being added at time 3, so we first calculate the accumulation from beginning until time 3. So the initial deposit is 100, and we know that under force of interest, the amount function is A of t equals P E 0 to t delta R dr. And the initial principal in this case is 100. So by time 3, it will grow to the P is 100 and e power 0 to 3, because we are trying to find what happens until time 3. And delta t was t squared by 100. So delta r would be r squared by 100, right? Delta t was t squared by 100. So delta r will be r squared by 100. And r squared integrates to r cubed by 3. So this would be r cubed by 300 from 0 to 3. And when you substitute r equals 3, this is 3 cubed by 300, and the lower limit makes it 0. So this whole thing simplifies to 109.42. So it means that the initial 100 by time 3 grows to 109.42, but then at time 3, a new deposit of X is coming. As mentioned in the problem, another X is added, time 3. So this total then becomes 109.42 plus X. And now this 109.42 plus X is what stays for another 3 years from time 3 to time 6. So this will grow. By time 6, it will grow to A of 6 equals, this was what we started with at time 3. So the reason why we take 109.42 plus 6 as the time 3 principal, because 109.42 is the initial accumulation, and then this X is added. So now the future interest applies to all of this, the 109.42, which was the initial accumulation after time 3, and then the X that was added at time 3. And so this grows from 3 to 6, again under the same force of interest. Same formula. P is now this 109.42 plus X, and time 3 now serves at time 0, because this principle is time 3 principle. So we are trying to see what happens by time 6. So we integrate from 3 to 6. So remember that 0 in the formula of amount function of force of interest, you always have to keep in mind, remember, you have to think of this 0 as the starting point at which the principal, at which basically the 0 is the time corresponding to when this principal is coming. So right now, this principal is coming at time 3. So the starting time instead of 0 would be 3. So once again, the integral would be r cubed by 300, and now the limits are 3 to 6. So the 6 cubed by 300 minus 3 cubed by 300, and all this sits in the power of e. And this whole thing simplifies to e power 0.63. And then we have this 109.42 plus x. So they say the amount of interest earned from time 3 to 6 is x, as given in the problem. So x would be a of 6 minus a of 3. And a of 6 is this one, 109.42 plus x, e to the 0.63, and a of 3 was 109.42 plus x. So it's very important that we take a of 3 as 109.42 plus x, because once you added the amount x, that became the amount at time 3 and not the original 109.42. And now we distribute the negative here, and this negative x when brought to the left side makes it x plus x, which is 2x, and then we subtract this term on the left side, so minus x e to the 0.63, and then 109.42 e to the 0.63 minus 109.42. So here you factor out an x and you get 2 minus e to the 0.63. And when you subtract these two, you get 96. And x would be obtained by dividing 96 with this factor, 2 minus e to the 0.63, and you get 784.61. And that rounds to choice E, which was 785.